there is a big question here. Do I want to have a big model that can do a lot of things, or do I want a small models that can do less things? Now, the frugality, that means for obtaining the results that you want to obtain, you basically don't use more resources than what's needed. And this is, of course, dependent on the problem you want to solve.
Welcome to the AI and Scale podcast. This is a show that invites AI practitioners and AI experts to share their experiences, challenges, and AI success stories. These conversations will provide answers to your questions. How do I implement AI successfully and sustainably? How do I make a real impact with AI? Our podcast features real AI solutions and innovations, all of them ready for you to harness, and offer a sneak peek into the future. Hi, I'm Gosia Gorska, and I'm the host of the Schneider Electric AI at Scale podcast. I'm really pleased to introduce Claude Le Pape-Gardeux, Data and AI Domain Leader. Claude is coordinating the evaluation of new technologies, the recognition of technical experts, the management of research and development projects, and partnerships in the data and artificial intelligence domain in Schneider Electric. Welcome, Claude.
Thank you, Gosia. Happy to be here.
Claude, I invited you to the show because I know that you have a huge experience in data and AI, not only because of your work in the field at Schneider, but also because you have 40 years of experience in the field. I know that you received a PhD in computer science from University Paris 11 and a management degree from Collège des Ingénieurs. During and after your PhD, you also worked at Carnegie Mellon University and Stanford University. Now, that's really impressive.
Yeah, I had the chance over my career to go to several very good places, both in academia and in industry, and to work in different fields of artificial intelligence. I've been having some activities in rule-based programming, in constraint programming, in machine learning, of course, but also in robots, task planning and path planning at Stanford. So this has been really great to work on very different topics and with always, practical problems in mind, in particular manufacturing scheduling, inventory management, things related to long-term human resources planning, and so on and so on. And of course, in Schneider Electric, things related to energy management.
Of course. Well, that's a really diverse topics. But what was your PhD thesis topic then?
So my PhD thesis topic was about the use of rule-based programming and constraint-based programming to improve manufacturing scheduling in specific plants. And in particular, there was a plant which was manufacturing the coaches for the first high-speed trains in France. So this was a good experience as well.
Wow. I didn't know about the trains, so that's really impressive. And I can imagine that you were like a perfect candidate to join Schneider, as we are a manufacturing company and we still have many plants and distribution centers all over the world. And I wanted to know at the beginning and understand, like, you have this really diverse background in all of this different research and development areas. But what was the most surprising thing about AI that got you in a positive or maybe negative when after your college times?
What has been always strange with AI is the ups and downs in AI popularity. It seems that, there are times at which people think AI is a solution to every problem, and then some other times where people think it doesn't work and so on. And this is totally unjustified. And my view is that AI techniques constitute a toolbox, and with this toolbox, you're able to solve some kinds of problems, and there are some kinds of problems for which it's not appropriate. And we need to be rational about these things and evolve to use AI in the best possible manner.
Yes, and I remember you also told me once that your work has always been at the frontier between AI and other disciplines like optimization, simulation, statistics. So where does your passion for this domain come from? When have you realized that this is what you want to do and this is what you want to explore exactly?
Yeah, when you start with a problem-solving point of view, so having really a problem that you want to tackle, being able to do things less costly or to do things more rapidly or to do things using less energy, you find out that there are techniques, that have been developed in different domains that can be applicable to your problem. You also find out that there are some subject matter experts who know a lot of things about their problem and that their knowledge can be very useful in building the solution. So I've very often been, in a situation where I was actually building some kind of hybrid artificial intelligence solution, and in particular between artificial intelligence and the field of operations research. There have been many cases where the right solution was a combination of both, done intelligently, of course, in order to achieve the best results.
Yes, I see. I was actually also wondering, it means that this practical aspect was really definitely important for you, right? The fact that you were able to apply these solutions, this technology to many different areas. And the reason that I also invited you today is like taken all your expertise and experience in this field. I wanted really to go deeper into especially one topic today that is related to the footprint, the carbon footprint of artificial intelligence, because this is the topic that we actually hear more and more about it. Everybody is having like great hopes towards artificial intelligence, as you mentioned, as a practical solution to many of the challenges that we are having. But we also hear and see that many people raise the question, okay, but what about the energy demand for artificial intelligence? Indeed, we can solve many challenges, but the more we want to use AI, especially large language models, the more energy is needed. And I even saw one opinion that basically we cannot move forward to develop more AI without any technology, like major technology breakthrough in energy, actually, because we need more energy to supply to AI. And I saw a concept that is called Frugal AI. So I wanted to understand, how would you define frugality of AI, and if you can explain a bit, what does it mean?
Yes, there are several aspects in your question. First, I believe it's a question for artificial intelligence, but also more generally for digital solution, whether you use AI or not. And the carbon footprint of using digital is increasing. And so some years ago, it was negligible in the total, and now it's no longer negligible. And so we need to care. Coming to artificial intelligence, there can be a very big difference between using very large models, which are expensive to develop and to use. When I say expensive, it's both in terms of cost and in terms of electricity that you need for that. And having simpler models that are less expensive to build, that will require less energy when you try to apply them, but that are going to be useful for more limited situations. And so there is a big question here. Do I want to have a big model that can do a lot of things, or do I want a small models that can do less things? Now, the frugality, I would tend to, the usual meaning of the word. That is, when you say you're going to have a frugal lunch, that basically means you're going to be eating simple food and just enough, not more than what you need to be in good shape. And so I would say the same thing for an AI application. That means for obtaining the results that you want to obtain, you basically don't use more resources than what's needed. And that means, having the right amount of data to build your system, having the right amount of complexity in the model you build. And this is, of course, dependent on the problem you want to solve.
Yes, but I had the impression that this term is not widely known, and that there is maybe some misconception about what exactly it means.
Yeah, so first, the word has been emerging recently, and mostly because people start to be conscious that there is a problem with the electricity consumption of AI and other digital solution. And second, there are indeed some debates about how you want to define frugal AI. So I gave, the definition I would prefer, which is to say, okay, you have a goal in mind, and this is why you do something, and you want to do it using less resources as possible. But some people are also considering that you need to look at the overall balance between what you use in order to put the AI system in place and what the AI system enables to save. And this makes sense when you say that you want to build an application to save energy or to reduce carbon emission and so on. Then indeed the right thing to do is to make some kind of balance sheet. I mean, how much do I use and how much do I save? And I'm happy, of course, if the savings are greater than what I use. And I want to optimize the difference between the two. I want to save as much as possible using as few resources as possible. In some domains, the objective of the AI application is not directly related to saving resources. If you just think, for example, of medical application where you use AI to be able to make better diagnosis of cancer or whatever, you're using energy and resources in order to save people's lives. And you cannot just put, these two things on the same scale. And you need to look at the advantage and, of course, the cost of the solution, but knowing that you have multiple criteria to look at.
So it seems that basically to whoever wants to apply AI or develop specific AI application, there is a list of questions or a list of decisions that they have to make, whether to use AI or not to use. And if you use AI, then how they can evaluate if the AI model, like if the way that they operate, the way that they approach AI is actually a frugal one. So how practically they can do it.
Yeah, so the first question is using some AI technique or using some other technique. There are obviously some cases where you don't need to use AI techniques. I will take the example where you have a problem and you can write exactly the equations that are representing that problem, and you know all the parameters in these equations. And to go to the extreme, let's say all these equations are linear, for example, then there is a technique from operations research that's called linear programming, and that is very efficient. And this is what you want to do. I mean, you don't want to run more complex procedures in order to solve your problem. So that's the first thing. I believe data scientists need to know not only the AI techniques, but the techniques from other domains in order to make a good choice. And then when an AI technique is needed, so for example, because you don't really know the equations of your problem or you don't know the parameters and so on, then you have some choices between trying to use a lot of data to have a very precise model or use less data and have a less precise model. And you need to think about it. And to think about it, the first thing is to consider what is it exactly that you need to do a good job with your application. I'll just take an example when we do some forecasting of the energy consumption of buildings. So you try to know, for example, for a building, how much energy will be used every hour of the next day. And then the question is, of course, the precision you need depends on what you're going to do with this forecast. In some cases, if you have a number that is good and the precision is 5-10%, then this error is acceptable. In some other cases, you need to be more precise. And so the frugality really means trying to make a compromise between the precision, the quality of the results, and of course the efforts you put in building the model and using the models.
Mm-hmm. And are there any methods to measure exactly if my approach is a frugal one or not necessarily? There is some area of improvement, maybe.
Yeah, so as of today, there is no real complete methodology, that data scientists can follow to make sure they make the best job. The first thing to do is to start to measure. And it's always like this when you want to try to optimize something and make the best possible trade-offs between multiple criteria. What you need to do is to measure. One thing we have been doing in Schneider Electric last year is that we have been taking 3 of our application involving some AI and making an estimate of what is the carbon footprint of using this solution. To be more precise, we did 3 things. Well, I'll just take one of these examples, which is the case of microgrid management. So a microgrid is a small electrical network that you install locally, and typically to enable the usage of renewable energy. So, for example, to enable a good usage of solar panels. And very often, if you put solar panels on top of the building, the solar panels may at some point deliver more energy than what the building needs. And so what is often done is to add, some energy storage devices in order to store the extra energy that you have at some point in order to reuse it later. And we have an AI system that is basically trying to do the best of the solar panels, of the batteries, and so on, and which requires first to forecast what is going to be the energy consumption of the building, the energy production of the solar panels, and so on, and then make some optimization. So what we did in this case is that we said that there are 3 things interesting. How much carbon emissions is my microgrid enabling? Compute that and estimate that. And for this, we use some simulation techniques. There is a second question that often people forget about, which is to put the solution in place, you have been investing in equipment. So you have been putting the solar panels, you have been putting the batteries, they have been manufactured somewhere. There was energy used and carbon emissions. And then you need to transport them, put them in place, and so on. So we also counted what is called the embedded carbon, of all the components of the solution. And then we did a third thing, which is to evaluate the carbon footprint of all the digital solution that manages the microgrid. And this enabled us, to have a first view, of what happens and to see on typical microgrids what are the basic numbers that we have and where we need maybe to try to improve.
Yeah, I'm really happy that you shared this example because I can think forward into the future and imagine a situation where it would be really great to have a label of every AI product or AI application that is actually informing you as a client how much carbon emission was involved into producing the application and then using the application. Because as I understand, our approach is really to measure this end to end, as you mentioned, from really literally counting what has been used even in the solar panels production that are being used. So this could be like a great feature to have more transparency in the AI market, because I think there are a lot of opinions about what AI can do and what's also the carbon footprint of these solutions. But here we are talking about facts and about solutions to really measure it concretely. So do you continue this work on this solution on our side? What do you expect to find out from this kind of evaluations?
Yeah, so we are doing two things. So first, we are investigating other examples, and we want this year, for example, to look at some examples with generative AI, which is a difficult case because in generative AI, we are using a big model that has been developed once and for all, and that is used by many people, and typically millions of people, if not billions. And so how do you count basically the cost of generating the model when it comes to your application? So this is a difficult question. There are other difficult questions. You're right. What would be great is to have the possibility to have some labels, and for this to have standards that would explain this is how you need to count. I believe it cannot be very precise because applications depend one from the other and so on. But at least the standard could say, here are the questions that you have to ask yourself. Here is what you need to document, and if you do the job right, yet indeed you can put a label and say that you've been doing a good evaluation. So this is another aspect of our work. As said, last year we've been making 3 examples, and how to go, from a few examples to methodology that we more systematically apply is, of course, a big question for the future. And it's a question within Schneider Electric, and it's a question more globally, because if there shall be a standard basically applied by everybody.
Yes, I really count on that. I think it's a great plan. So, Claude, you explained how we check if AI is the right solution for the business and how to measure if it's going to be efficient or not. And now I would like to open the topic of continuous improvement. This is very close to my heart. And I know at Schneider overall, we also really empower this approach of improving things over time and always striving for the best solutions. And as looking at your papers, you mentioned in one of them that overall improving efficiency over time is needed. So could you explain this and how we can do it in practice?
Yes, so basically, once you are able to measure things, you can start seeing the numbers and ask yourself, how can I improve on these numbers? So I'll give you a few examples. For example, to do the forecasting of the energy consumption of the building, there are several ways that you can use to do that. One is to get a lot of data on this particular building and build a specialized model for this building, and then use this model. So this requires to gather a lot of data for each building and then develop a model especially for it. And the question is, can we do something in a sense simpler? In particular, if we have some other buildings that we have been treating in the past and that have commonalities with the building that I have at hand. So we have started some work on what we call cold start forecasting, and which is basically trying to do forecast with little data. So instead of gathering a lot of data about the past, you just look at the last 2 weeks, and instead of trying to develop, a model especially for that, you look at whether you can see that this building is close to another one and adapt the model you have for another one. So the complete environmental study is not fully achieved yet, but we have first results showing that it's a good route to follow, and I hope we can show that indeed it's better. Of course, there are also cases where you don't have the data at all. So if you don't have the data at all, you have no choice. But there are cases, where the data exists, but getting the data in one place and so on is very costly, and we want to avoid this cost. And we see that here you can think about cost, in monetary terms, and of cost in environmental terms.
Mm-hmm. And can we imagine also in the future that I will be able to compare how my buildings operate thanks to some of the AI applications, but also compare them versus other buildings existing in the same region, let's say?
Yes, it's also another thing that can be done, is actually this can be done with rather simple models. If you take standard buildings, like office buildings, I'm not talking of factories and so on, where you have energy consumption depending on what you manufacture. But if you take, for example, office buildings, basically in office buildings, when you consider heating and air conditioning and ventilation, the energy consumption is basically very closely related to the outside temperature. And so we have been building what we call the building energy modeling tool in order to see what is the relationship between the energy consumption and the outside temperature. And you can do that at several granularities. You can look at it at a global monthly level or look at it at a daily level. Daily level for office buildings is often interesting because, of course, weekdays and weekends are not similar, and weekdays can also differ one from the other. For example, now because some people do some working at home and so on, and so there are differences between the weekdays, and you can have these models, and this model can allow you to do two things. First, to look at a given building compared to other similar ones. And second, when you make improvements, to really evaluate these improvements, disregarding the fact that the climate in a given year is different from the climate in another year. So very simple models that are very useful to know what you're doing.
Yes, and I think this is great that we have this research inside of Schneider, but do you also cooperate with academia? You mentioned that some of the efforts in this area cannot be done by just one company, right? We probably need some cooperation. So how are your team or you particularly cooperate with research centers, with academia?
Yes, so academia, we have really strong competences here, and people having many ideas, working on some problems, for which there will never be a perfect solution, but bringing ideas to improve. So it's very important to follow what they are doing. And we cooperate in several ways. First, we can, in some cases, are funding a particular chair or a particular lab to do some work on some topic. Second one is having PhD students who spend half of their time in the academic laboratory and half of their time in Schneider Electric, and so we are both, connected to the latest progress in the field and the applications we have in Schneider. And this leads, of course, to academic papers, but also to patents and to some ideas that can, in the end, go in our offer.
Okay, so I'm sure that now whoever is listening from the students of maybe earlier years, you can see and hear now what are the research areas at Schneider, and you can think about joining us for your PhD thesis development as well. So, Claude, I would really like to move on with the conversation. I'm looking at the clock, and we are at the end of the time. So, what would be your final message to our listeners?
Yeah, so first, having in mind that there exist many AI techniques and techniques from other fields, and so that you really need to think about choosing the right technique for the problem that you want to solve. To do this, you often need to focus, on compromises, the quality of your results versus the resources you put to have this resource. And in some cases, the things are in the same dimensions. You make an application to save energy, and you count the energy you use to save that energy. And in some cases, it's in different dimensions, and then it's a matter of a compromise and have the right, person to decide what is the best trade-off.
Mm-hmm. Yeah, thank you very much, Claude. I really appreciate your time with us, because I think thanks to this kind of conversations, we make AI less of a black box and more of something that we can understand, we can measure, and we can even improve over time. So thank you so much for being with us today.
Thank you. Thanks again for the invitation.
Thanks for joining us today on AI at Scale podcast. Be sure to visit our se.com/AI website and learn more about our AI at Scale solutions. Head over to our Schneider blog platform to read more. Don't forget to subscribe to the show on your preferred platform and share it with your network. Thank you for listening, and stay tuned for the next episode.